Okay, so that's lesson number 1. The lesson is that it's actually very unconventional to try and predict the stock price in the first place. Instead, what we really want to try and predict is the stock return. The return is defined as follows. For a given period of time, the return is the final price minus the initial price divided by the initial price. Now, just for some intuition, this is the same formula you would use when you want to calculate a sale. So for example, what does it mean when we say something is 20% off? Intuitively, you know that if something costs $100 and it's 20% off, then you'll pay $80. But we can also calculate this another way. Take 80, subtract 100, and divide by 100. That's minus 20%. In other words, the price you pay is 20% less than the original price. So to summarize, when financial engineers do quote-unquote stock prediction, they are usually looking at some form of return, not actual prices. Okay, so back to the code. Since we're working with a pandas data frame, this is somewhat convenient, at least if you know the right functions to call. As usual, we want to process our data in a vectorized form, meaning we do some operation on all the columns at once. So first, we need to shift the closing price up by 1, so that yesterday's closing price is aligned with today's closing price. So x of 2 is beside x of 1, x of 3 is beside x of 2, and so on. Then we can subtract them all in one step. So let's do df.head to look at the result. Now, as you can see, the first row is NAN because we don't know the previous price for that row since it's not in our data set. This is not a problem for us because we are building an RNN. It's going to take the first 10 days of data to predict the 11th day. So that would be from here up to the 10th row. So we never even use this value. All right, so the 11th row is much further away than the first row. So if the first row has NANs, as long as they are not in the target, that's fine. Next, we do our return calculation. So we say df return is equal to df close minus df previous close divided by df previous close. Let's do a df.head again to look at these returns. Okay, so again, the first value is an NAN, but we don't care. Next, we do a plot of this time series. Conceptually, this is no different from the stock price or a sine wave. It's still just a time series. But as you're beginning to see, some time series are harder to learn from than others. Next, we draw a histogram so we can see the distribution of returns. We can see that these are pretty small values, so we might want to normalize them. So we're going to go through the same thing again, where we assign the returns to a variable called series as an n by 1 matrix. Note that here I'm taking dot values at the index 1 and up because the 0th index is an NAN. As before, we create a standard scalar, call fit on the first half, and call fit transform on the whole thing, and then flatten it back to an n-length vector. Next, we are going to go through all the same steps to build our supervised learning dataset and train our autoregressive RNN model. This code again isn't any different than the previous code. It's only the data itself that's different. Because now we are working with the series as the return rather than the actual stock price. Okay, so here's the data. Here's our RNN model. And here's the result of training. So the loss starts out at about 1. And then by the end of training, the loss is about 0.87 and the test loss is about 1.5. So it's pretty clearly overfitting. What we can see from this is that the model has a much harder time learning anything. If we look at the loss per iteration, it looks like the loss goes down a tiny bit, but only at the cost of the validation loss going up. In other words, it's just fitting to the noise. Next, we're going to do a one-step forecast. And so here are the results. Now, it's hard to tell whether this is good or not, but judging by the previous loss values, it's probably not good. As an exercise, you might want to try to run this locally so that you can zoom into the plot and check for yourself. Next, we're going to do a multi-step forecast. Okay, so here are the results for the multi-step. So again, we have this situation where the model doesn't really match up that well with the actual time series.